This week we're starting 2 weeks of organic chemistry. Organic chemistry is the chemistry of carbon. Biochemistry is a sub-branch of organic chemistry. And the reason that carbon is so interesting is because of its structure, it can form an enormous different number of compounds. And the whole branch of organic chemistry is a subject of its own, apart from physical chemistry and other branches of chemistry. So this first question, question 6, asks why these two isomers or two molecules are not isomers. You'll remember the definition of an isomer is they have the same chemical formula but a different structure. Now clearly these two have a different structure, but if you look at the formula of the first one, it's 1, 2, 3, 4, 5, 6 with 12 hydrogens around the outside. If you look at this one, it's the same number of carbons, but then there are 7 on this side, and 3 is 10, and 3 more is 13, and 1 here is 14. So on this one you have C6H, so they don't have the same chemical formula. Therefore they are not isomers. The next one is problem number 10. Problem number 10 says write the formula, the condensed formula, and the Lewis structure for each of the following. I'm going to do a couple of these. I'm not going to do all of them because that would take a long time, and I don't think I have to do them all. If there's any particular one you can't figure out, just let me know. And let's start. It says write the chemical formula. So heptane. Now, the first 10 carbons, you need to make sure you understand the prefixes. So it's methane, then ethane, then propane, then butane, then pentane. So that's 5. Hexane, and then heptane. Heptane means that you have 7 carbons. Now the basic formula for all alkanes, which is what this is an alkane, is C to the N, H to the N, 2N plus 2. So 2N plus 2 says that this is 7 times 2 is 14 plus 2 is 16. So that's the formula for heptane. The condensed formula well, there's several different ways we can write this. You can write C, 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 1, 2, 3, 4, 5, 6, 7, and then hydrogens around the outside like this. And then another way that you can write this, and I'm happy with any of these, by the way, as long as you be careful and make sure you do it right. So that's one way to do it. Or you can do CH3, CH2, 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 1, 2, 3, 4, 5, 6, and then CH3. So that's another way you can do it. Or you can do it like this. Now each point, 1, 2, 3, 4, 5, 6, 7. So that's another way to write it. So any of these are potential ways of writing it. The Lewis structure of these looks like this, and I'll fill this in just a minute. Because there are no double bonds, everything has a single pair between each carbon. So we have 1, 2, 3, 4, 5, 6, 7. Then you have hydrogen with a dot and a dot, and a hydrogen with a dot and a dot, and a hydrogen with a dot and a dot. And you go right down the line the same way. And I'm not going to do all of these, but you see the pattern. So that's the Lewis structure. Now just for the heck of it, let's look at heptyne. Y and E tells you there's a triple bond. The 2 here tells you the triple bond is on between the second and the third carbon. So you have C, single bond, C, triple bond, C, single bond C, single bond C, single bond C. 1, 2, 3, 4, 5, 6, 7. Okay. Now, if it were over here, yes, it's still on the second carbon, but it would just be just heptine. If you're in the first position here, then it's just heptine. If there's a 2 there, that means that it has to start here. And so you would have the same sort of output here, except here there would be no hydrogens, because between these two there's no hydrogen here, there's no hydrogen here, but there's still hydrogens all around the rest of these. So it would be like this, and so forth. Now the other thing I'll show you is with the Lewis structure, you have C dot dot C, and then you've got dot 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 C, and then dot dot C, so that you have 3 pairs to represent the triple bond here, and then the rest of your C's are out here, and your hydrogens are similarly placed. But again, because this is all already fulfilling the rule of octet, you don't have any hydrogens around this carbon or around this carbon. So it's out this way, but not on these 2 carbons here. Now, if you have any questions about any of the other of these, you can let me know, and I will go over them with you. Now, I believe, let me take a look here. Yeah, let's see. The next one is 12. Let's move to 12. It says, give the complete IUPAC name for each of the following. Okay, and we'll do 3 or 4 of these. I'm not sure I'll do them all, but we'll do each one of these. So let's take this first one. Now, if you're having trouble figuring out what that looks like, you can draw it. So let's put the C here, and what they're telling you is you have a CH3 here, and then a CH3 here. So there's two of those on a C, and then you have F, okay, on this one, and an H. Okay, now when you name these, you have to figure out what the longest chain is. And the longest chain is, you put your pencil down, how many carbons can you cover without lifting your pencil or retracing your steps? So in this case, I was able to draw through all 3 of these carbons without lifting my pencil or retracing my steps. And so then you have 1, 2, 3. So that's pro, like propane. And indeed, there are no double or triple bonds, so it's propane. And that's the base. And then you have an F coming off that propane. So it's fluoro, if I could spell, propane. And then the last point is that F is not on the end, it's in the middle. So it's 2-fluoropropane. So that's the first one. Look at this one. This 1, 2, chlorine in there, 3, 4. So let's draw it this way. 1, 2, 3, 4. And then we have on the, looks like the second carbon and the third carbon, we have a chlorine. So on the second carbon and the third carbon, we have a chlorine. And then hydrogens, well, there's a couple ways we can put in the CH3 here. This would be H, this will be H, and then CH3 here. So again, the first step is to put your pencil down and see how far you can go without retracing your steps or lifting your pen. And sure enough, it's all 4 of these, and that's bute. And because there are no triple bonds, well, let me move this over. I'm going to need a little more room here. So it's bute. And there are no triple bonds, so it's butane. Then you have a chlorine here and a chlorine here, so 2 chlorines. So that's dichloro. Now with the dichloro, it could be here and here. It could be here and here. It could be any. In order to signify this, you've got 1, 2, 3, 4. So this is 2,3-dichlorobutane. 2,3-dichlorobutane. Now they drew the next one for us, so let's do that. So let's put our pencil down, and we can go this way, that's 3. We can go this way, and that's 4. You always select the longest one that you can draw without lifting your pencil. So you go this way, you've got 4. So that's bute again. And again, no double bond, so it's butane. And now you have this one group that sticks out once you've eliminated all these right here. And that group is a single carbon group, so it's a methyl group. Now, in this case, if you put the methyl group on either end, it would go from being butane to pentane. So you don't have to, and if you put it here instead of here, it would be the same molecule, because putting it here is just flipping it over. And so in this case, since it doesn't matter where, the only way you can write this is the way it is. You don't have to put a 2 in front of it. If you do put a 2 in front of it, I will not necessarily count it wrong. Let's go on let's go on and do, I think the next one we're supposed to do is 14. Yeah, the next one is 14. Write the Lewis structure and name the 5 structural isomers of hexane. Now this is kind of an interesting practice. Okay, so we have hexane. So we've got, and I'm going to do it quickly here, and you can fill in the blanks. So you've got 1, 2, 3, 4, 5, 6. So that's 1. Or you can do it this way if you want to. 1, 2, 3, 4, 5, 6. Then you can write 1, 2, 3, 4, 5 and put a C here. And you can do 1, 2, 3, 4, 5 and put a C here. Now, if you do 5 again and put a C over here, that's the same as putting a C here, because it's just flipping it over, so that doesn't count. But you can do 1, 2, 3, 4 and put a C here and a C here. Okay? I don't know why that changed into a circle. It's not supposed to be a circle. So that's another one. And then the last one is 1, 2, 3, 4. Put a C up here and a C down here. Or you can put them beside each other, it doesn't matter. So there's your 5 isomers. And you know, if you want to draw the Lewis structure for those, you can put dot dot, like this, and so forth. And then surround it with your hydrogens. But there's the 5 isomers of hexane as asked for. The next one is number 18. Number 18 says, write the Lewis structure and the IUPAC name for the alkene isomers of C4H6. So you have C, 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 C. Now, the standard formula for a alkene that has only one double bond, wait, is it alkene? Alkyne, excuse me, has one triple bond is C to the N, H to the 2N minus 2. So here we have C4, And 2N is 8 minus 2 is 6. So that's the standard formula, and that's what we have here, C4H6. So they're asking for the alkene isomers. So you have 1, 2, 3, 4. Now you can put a triple bond on the end. Now if you put a triple bond on the other end, it's the same, it's just flipped over, so that doesn't count. Or you can put a triple bond in the middle. Now another option is you start out with 3 and you put one guy down here. Now can you put, and indeed you can put, a triple bond. You cannot put a triple bond here or a triple bond here, because what happens is you don't have enough. Let me show you. Let's take this out. Now you have 4 bonds here, then there's nothing left to attach here, and similar if you put 3 here, so that doesn't work. So this one doesn't work. So these are the 2 isomers of this alkene. There aren't any other choices here. If you moved one, say put a carbon in the middle here, then there wouldn't be a bond for this side. So you just, these 2 are it. Then it asks for the IUPAC names for these. So both of these would be butine. And the first one, you don't have to, when the answer is 1, you don't have to say 1. So that's the IUPAC name for the first one. And for the second one, it would be 2-butine. And you always use the lower number. You're thinking, well, why not 3? You always use the lower number. So we'll stop at this point and do the rest on the next tape.